This is section 6.1 for MA 259, the second video. So this is question number 6. So once again, what we're going to do is try to find the critical points. And so in order to find the critical points of this system of differential equations, what we would do is set them equal to 0. So 2 minus 4x minus 15 times y equal to 0 and 4 minus x squared equal to 0. So both of these got set equal to 0, and then that way we can find the critical. So from this second equation, I solved for the fact that x has to equal either positive or negative 2. So then I ran both cases through the first equation to figure out what y is. So if x is equal to negative 2, I plugged in x is equal to negative 2 and solve to get y was equal to 2/3. So that means one of the critical points is at negative 2/3. Then I put in x is equal to 2, and when I put in x is equal to 2, I solved for y is equal to negative 2/5. So that other critical point is at x is equal to 2, y is equal to negative 2/5. So that means something is happening with this system of differential equations of importance at two places, and those two places are these two critical points, negative 2/3, and 2 2/5. Those are the two places. And in your book, I matched that up with figure 6.1.18. And once again, in section 6.2, we'll talk more specifically about how to identify what's happening there. But for now, I want us to just figure out where things are actually happening. Where are the nodes of interest? I found from the web someone else used GeoGebra to draw this phase plane. And this is the point negative 2/3. Is clearly there. But the other one, 2 minus 2/5, so this is 2 and then minus 2/5 would be here. Their software is not really identifying anything that's happening here, but there is another node of interest right in there. So in section 6.2, we'll talk specifically more about how to classify and identify those nodes in a succinct way.